Okay, good morning, everyone. Thank you for the opportunity. Now I'm going to presenting about chapter 11, a study case about Alfie Florist, chapter 11, two sample tests of hypothesis. So for the introduction, I'm going to be explaining the meaning of hypothesis, just like in the previous chapter, chapter 10. So what is hypothesis? In statistics, a hypothesis is a statement or claim about the population that is being studied. The hypothesis is typically expressed in terms of one or more parameters that characterize the population, such as its mean, variance, and proportion. Hypotheses in statistics are used to make inferences about the population based on a sample data and to test the validity of the statistical models or theories. Here's 5 steps process of hypothesis testing. We still use this steps process of hypothesis testing. First, we're going to set the null hypothesis and alternative hypothesis, which is the default assumption, where the alternate is that we're trying to prove or disprove. Then we move to the step 2, is choose a significance level, where we determine the level of significance for a hypothesis test. Next, we move to step 3, that is define test statistics, where we use a test statistic to determine whether the step 1 is accepted or rejected. And moving to step 4, that is define decision rules, where we're going to check the critical value from the test statistic that has been tested. And the last one is make H0 decision and interpret the result. So comparing to population means if the standard deviation known, we can use the following formula to compute Z. Following formula to compute Z, to sample mean test, sigma or standard deviation is known. The formula is Z equal x bar 1 minus x bar 2 divided square root sigma sigma 1 square 2 plus n1 divided n1 plus sigma 2 square 2 divided n2. Assumptions that must be met. First, the two samples must be unrelated or dependent. And the second one is sigma or standard deviation of the two populations must be known. So here's the example. Alfie Florist wanted to compare the height increase of sunflowers using fertilizer product A with product B. For these samples of sunflowers, using fertilizer product A increased an average of 7.6 centimeter in 3 months. For product B, the population standard deviation of the sample is 2.4 centimeter. 55 samples of sunflowers use product B with an average increase of 8.1 centimeter. The population standard deviation is 2.9 centimeter. At the 0.05 significance level, we can conclude that sunflowers using product A gain less weight. So here's the answer. Are known, N1 is 40, X bar 1 is 7.6, and a sigma or standard deviation is 2.4. And N2 is 55, X bar 2 is 8.1, and sigma or standard deviation is 2.9. And the alpha is 0.05. So H0 equal mu1 equal mu2, or H0 equal mu1 more than equal to mu2. And H1 equal mu1 less than mu2. And the alpha is 0.5 minus 0.05 is 0.45 The typing point is 1.65. So reject H0 if Z count less than 1.65. So Z equal 7.6 minus 8.1 divided square root of 2.4 square 2 divided 40 plus 2.9 square 2 divided 55 is minus 0.5 divided 0.54 is minus 0.93. So reject H0 if minus 0.93 more than minus 1.65, then we accept H0. And the next one is two samples test in proportion. The formula that we use is Z equal P1 minus P2 divided square root of PC 1 minus PC divided N1 plus PC 1 minus PC divided N2. PC is accumulated proportion. So the accumulated proportions formula is PC equal X1 minus X2 divided N1 minus N2. So here's the example for the previous slide. Healthy florist observed 100 roses from the first garden indicates that there are 70 white roses. Then observe 150 roses in the second garden has 90 white roses. With a significance level of 0.05, can we conclude that the sample in the first farm is larger than the sample in the second farm? And here's the answer. Are known. N1 is 100, X1 is 70, P1 is 0.7, and N2 is 150, and X2 is 90, and P2 is 0.6. So H0 equal mu1 less than equal to mu2, and H1 is mu1 more than mu2. So the alpha is 0.5 minus 0.05 is 0.45. So the typing point is 1.65. Reject H0 if Z count more than 1.65. So the PC is 70 plus 90 divided 100 and divided 100 plus 150 is 0.64. And Z equal 0.7 minus 0.6 divided square root of 0.64. 1 minus 0.64 divided 100 plus 0.64, 1 minus 0.64 divided 150. So the hasil is 1.613. So the conclusion is 1.613 more than 1.65, then we accept H0. So that's it from me. Thank you guys for your attention and have a good day.